Hello everyone, welcome to the chemistry session on corrosion control. In the previous session, we have seen what is corrosion and what are the types of corrosion, electrochemical theory of corrosion, and also factors affecting the rate of corrosion. In this session, let us see the corrosion control methods, mainly cathodic protection and metal coating techniques. So, dear students, corrosion of metal can cause numerous problems in the environment. For example, transport of drinking water may be mainly influenced by the corrosion of metals. It can also cause problems in storage tanks, pipelines, ships, cars, plant bridges, in transport facilities. When the structural integrity of these facilities is weakened by corrosion, the environment and public safety are threatened. Therefore, it is necessary to control or to minimize corrosion of metals. It's very difficult, to stop the corrosion 100%. But we can minimize it considerably. Diverse methods are used to control corrosion, as the corrosion is a reaction between the metal or alloy and the environment, and method of corrosion control must be related to modifying the metal or the environment. In order to protect metal from corrosion, we need to develop a barrier between the metal and the environment. As a result, a direct attack of environmental constituent on metal can be stopped. We can use the techniques like metal coating technique, painting technique, or just changing the design of the metals, or by reducing the use of two dissimilar metals. As you know, two dissimilar metals, when in contact, it undergoes galvanic type of corrosion. We have to improve the design techniques of pipelines. We can have inorganic coatings, anodizing techniques, phosphating techniques, or hot dipping process, metal coating techniques. And today in this session, let us concentrate on cathodic protection. So, under cathodic protection, we have sacrificial and impressed current techniques, and under metal coating techniques, we have galvanization and tinning. So, first let us see what is cathodic protection. Cathodic protection is defined as the method of protecting a metal or alloy from corrosion by converting it completely into cathode. Generally, in all types of corrosion, oxidation and corrosion occurs at anode. Therefore, it is necessary to protect anode or stop oxidation. In this method, the active metal which involved in corrosion is converted into inactive metal by connecting it with more active metals like magnesium, zinc, or aluminum. In this picture, you can see the steel pipe has to be protected is connected to a highly electropositive metal, highly active metal like magnesium. Now here magnesium being highly electropositive, when it is connected to the metal iron, it is less electropositive compared to magnesium. Therefore, now magnesium acts as an anode and the metal to be protected is converted to cathode. So, it becomes cathode. This is anode. Since here magnesium is highly active, during corrosion, this magnesium completely sacrifices. It undergoes corrosion, thereby protecting the steel pipe. So, in place of magnesium, we can use highly electropositive metals like zinc or aluminum, or sometimes their alloys, in order to protect the base metal. Now, here you can see the ship part is protected by connecting magnesium blocks. Now, here the magnesium block connected acts as a sacrificial anode. As a result, the metal or the parts of the ship which has to be protected is converted into cathode. This propeller and this metallic part or entire part of this ship is protected by connecting the sacrificial anode. Now, this metal that is connected, being highly electropositive, completely sacrifices. There is corrosion at this region. Now, here the metal that is undergoing corrosion is this magnesium bar. It is being highly electropositive. It is more susceptible for oxidation. It loses electrons, and this sacrificial anode completely withers. It undergoes complete destruction. As a result, the cathode portion is safe from corrosion. So, this sacrificial method of corrosion is under cathodic protection. Now, in this cathodic protection, metal to be protected is converted as cathode by connecting a highly electropositive metal like magnesium, zinc or aluminum, which completely sacrifice. Now, when it comes to cathodic protection, now this cathodic protection is generally used under water structures, the protection of underwater structures, pipelines, platforms, wind turbine foundations, wave and tidal generators, quay and harbor walls, ships and boat hulls, portable water tanks and storage tanks. Now, the next technique is impressed current method. Now, here you can see the metal to be protected. For example, let us say the tank. Now, let us say it is made up of iron. It has to be protected. So, how we can protect it? Now, here we need to supply the DC current, which must be impressive so as to stop the corrosion. So, we need to have the anode which is generally inert, which should not undergo any corrosion. So, the positive terminal of the battery is connected here and the negative terminal of the battery is connected to the tank which has to be protected. Now, in this method also, the metal to be protected is converted into a cathode. That is why this impressed current method and sacrificial anode method. In both the cases, the metal to be protected is converted into a cathode, hence it comes under cathodic protection. Here you can see the cathodic protection. Now, here the method used is impress current technique. So, here we have some anodes which are said to be inert. They do not undergo corrosion. It is connected to the positive terminal of the battery, and the metal to be protected is connected to the negative terminal of the battery. You see the corrosion current, how it is flowing. Now this is sacrificial, this is impressed current technique. See, the electron source is magnesium here, anode, and here you see the platinum being the inert one, and the cathode is metal to be protected. This is how the impressed current technique and the galvanic technique. Or here also you can see in the picture, in the impressed current technique, this is the electron source, DC current. So positive terminal is connected to the inert anode, platinum, and the negative terminal is connected to the cathode, the metal to be protected. Here you can see. So once again, the impressed current technique. Here metal to be protected is converted into a cathode by connecting to the negative terminal of the DC battery, and the graphite or inert anode is used. Graphite or platinum etc. are used as a inert anode, and it is connected to the positive terminal of the battery. In both impressed current technique as well as in sacrificial anode method, the metal to be protected is converted into a cathode. Hence, it is called cathodic protection. Dear students, now let us discuss about metal coating techniques. Here it is said to be a hot dipping process. The process in which more active or less active metal is coated over the substrate or base metal. When it comes to most active metal like zinc or magnesium is coated on the surface of a base metal. When it comes to less active metal coating, we can use tin. When the tin metal is less reactive metal if it is coated on the surface of base metal. So based on this active anode and less active cathode, we have metal coating techniques. We have anodic coating technique and cathodic coating technique. See, when metal like zinc is coated on the surface of a base metal, it is called anodic coating. So coating of zinc on the surface of base metal is called galvanization. And similarly, the less reactive metal like tin, stannum, if it is coated on the surface of base metal, then it is called cathodic coating. So metal coating, under that we have two types. One is anodic coating and cathodic coating. For anodic coating, we have example galvanization. And for cathodic coating, we have tinning as an example. So let us see what is the technique of galvanization and tinning separately. So galvanization is nothing but a process of coating a base metal surface with the zinc metal. So this galvanization as well as tinning is carried out by hot dipping process. So tinning is nothing but a process of coating base metal surface with a tin metal stannum. So both these techniques are carried out by hot dipping method. So galvanization is nothing but coating base metal with zinc, and tinning is nothing but coating base metal with metal tin. Now in galvanization, the base metal acts as a cathode and zinc acts as an anode. In tinning process, base metal is anode and the tin metal that is coated on the surface acts as cathode. That is the difference. And both these techniques are called metal coating techniques. Now let us see the steps involved in galvanization. So as you know, galvanization is nothing but coating the base metal with zinc. So the first step involves, washing the metal surface with the organic solvents. The impurities like oil or grease or organic deposits, it has to be removed by washing with the organic solvents. And the next step is pickling process, where the rust and other deposits are removed by washing with the dilute acid. And the article which is subjected to galvanization are washed with water, and it is dried using air. And next, the hot dipping process, where the article or metal to be coated is dipped in a bath of molten zinc, maintained at about 425 to 430 degrees Celsius, and which is covered with a flux of ammonium chloride to prevent the oxidation of molten zinc. The excess of zinc that is present on the surface is removed by passing through a pair of hot rollers, or it can be removed using different rubber rollers which can wipe out excess of zinc coating, and it produces a thin coating of zinc. So as you know, galvanization, it is a hot dipping process. So here we need molten zinc, then the flux. Now this flux, ammonium chloride, plays very important role. When the metal like iron, when it comes in contact with molten zinc, due to the hot nature of that liquid zinc, so metal that has to be protected may be converted into its oxide. Metal surface may, so in order to prevent that oxidation, so that molten zinc should not oxidize, it should coat on the surface of base metal in the form of zinc. To prevent that oxidation, so we are using ammonium chloride flux. Now here I'll show the small video how actually it is done. Now here in this video you can see how the process of galvanization is done in the industries. So large quantity of metal iron is protected by developing a layer of zinc metal on the surface. Now initially washing with water, then treatment with alkalis or base, or treatment with organic solvents, and washing with water, hot water, and drying, and placing or dipping the metal to be protected in molten zinc. So there are different compartments where metal to be protected is exposed. So the exposure time and the solvent used, it's a plays very important role. Now galvanization as a result protects the base metal completely. A layer of zinc is established on the surface. As you know, zinc is more active metal compared to the base metal iron. So it is being more active, it undergoes corrosion, and it is acting as an anode and converts the base metal into a cathode. Now here the technique involves just developing a layer of metal on the surface. Therefore it is called a metal coating technique. As you said, as we discussed earlier, so metal has to be washed properly in solvents and water, and then the pickling process is also used. The process where the metal, base metal, is washed with the dilute acid like sulfuric acid. Once it is once the surface is ready for galvanization, it is dipped in hot molten mass of zinc, maintained at around 430 degrees Celsius. Metal is exposed to molten zinc for few minutes and a few seconds depending upon the requirement of coating. Then it is lifted. Then the excess of zinc that is present on the surface is wiped off. We can completely change the surface of metal to be protected. We know the zinc, it is the shining metal and it is more active, of course. So a layer of zinc is formed on the surface of metal, and the article which is subjected to this hot dipping process is called galvanized articles. This is how it looks at the end. The metal is completely protected by developing a layer of zinc on the surface. Once this layer of zinc is established on the surface of base metal, the base metal is safe. So one of the important corrosion control technique is used in order to protect the metal. Dear students, thank you very much for watching this video, and I request all of you to go through this video lecture on corrosion control, and I may upload some assignments related to this. You can look into your Google Classroom, and I'll get back to you with another session video explaining about the metal finishing techniques. Thank you very much. Be at home and be safe. Thank you very much.